In this session, we will discuss few questions from analog electronics. These questions are asked for previous Kerala PSC exams. Here we have first question. One main application of positive feedback is option A, high stable amplifier, B, high power amplifier, C, low noise amplifier, option D, oscillators. The correct option is option D, oscillators. Oscillators have positive feedback configuration. It consists of an amplifier in forward path and feedback network. If the feedback signal is in phase with the amplifier input signal, then the feedback is called positive feedback. So we have an amplifier in the forward path with gain A and a feedback network with the gain beta. The feedback signal is in phase with the input signal. Let Vi be input voltage, output voltage be V0. So this is positive feedback configuration. The overall gain, that is V0 by Vi, magnitude of V0 by Vi equal to A by 1 minus A beta. A by 1 minus A beta for positive feedback configuration, where A and beta are functions of frequency. At a particular frequency, when A beta become equal to 1 angle 0 degree, that means magnitude of A beta become unity and angle of A beta become 0 degree or 360 degree. Denominator of the gain becomes 0. That means there will be a finite V0 even if Vi tends to 0. Under this condition, there will be a finite output when input becomes 0. And this condition is called Barkhausen criterion. So correct option is option D, that is oscillators. The monostable multi-vibrator has option A, 2 stable states, option B, 2 unstable states, option C, 1 stable and 2 unstable states, option D, 1 stable and 1 unstable state. Multi-vibrators in general produce a square wave output and are the most commonly used for the generation of square waves. So multi-vibrator circuits are used mainly to generate square waves. So monostable multi-vibrator has 1 stable state and 1 unstable state. The duration in which the circuit will be in unstable state, that is time period of unstable state, is determined by the value of time constant, timing capacitor C and resistor R. Correct option is option D, 1 stable and 1 unstable state. Next question. Which of the following oscillator are not suitable for very low frequency application? Option A, RC phase shift oscillator. Option B, Wien bridge oscillator. Option C, Hartley oscillator. Option D, unstable multi-vibrator. The correct option is option C. Hartley oscillator cannot be used for low frequency application as it would result in large sized inductor which makes the circuit bulky. So in Hartley oscillator, the frequency is determined by 1 by 2 pi into root of LC. So the value of inductor L is very large if frequency F to be small value. The correct option is option C. Next question. Oscillators use options A, degenerative feedback, option B, no feedback, option C, regenerative feedback, option D, none of the above. Oscillators use positive feedback. That is, the feedback signal is in phase with the input signal. The positive feedback is also called regenerative feedback. So correct option is regenerative feedback. Feedback amplifiers use negative feedback, which is also known as degenerative feedback. The overall gain in degenerative feedback is A by 1 plus A beta. In regenerative feedback, overall gain is A by 1 minus A beta. So correct option is option C. Let us move on to next question. The function of oscillator is option A, to generate DC from variable frequency AC. Option B, generate variable frequency AC from DC. Option C, generate DC power. Option D, generate high frequency power. Oscillators are used to generate high frequency signal or power. The frequency of oscillator remains a constant value, so the correct option is option D. Next question, if the charging time constant of an unstable multi-vibrator is 0.001 second, what is the frequency of oscillation? A stable multi-vibrator is used to generate symmetrical or asymmetrical square wave pulses. If we consider a symmetrical square wave pulse, the on time and off time will be same. It is given that the charging time constant R1 C1 equal to 0.001 second. Let's assume that it will produce a symmetrical square wave. So R2 C2 discharging time constant will also be the same value. So R2 C2 will be equal to 0.01 second. The overall period T is equal to T on time plus T off time. On time is determined by the formula 0.693 R1 C1 plus off time is 0.693 into R2 C2. Therefore, overall period will be equal to 0.693 into R1 C1 plus R2 C2. We know that R1 C1 equal to R2 C2 equal to 0.001. So time period will be 0.693 into 0.002, because 0.001 plus 0.001 will be 0.002. Answer is 0.001386 second. Therefore, frequency F equal to 1 by T. Frequency F is given by 1 by time period. The value will be 1 by 0.001386 and the value is 724.6 Hertz, approximately equal to 725 Hertz. So correct option is option C.